During this week's Pulmonary Function Lab, we'll be examining some of the tenets and principles surrounding ventilation. With that, we have a series of changes that occur within the thoracic cavity, and as you inhale, you use these inspiratory muscles, and collectively these respiratory muscles cause an increase in thoracic volume. That increase in thoracic volume, or inhalation, results in a decrease in intrapulmonic pressure. And as a result of the change in pressure, air will then find its way into the lungs. As a person exhales, these expiratory muscles contract and decrease thoracic volume. And when we contract and we decrease the thoracic volume, we're increasing the intrapulmonic pressure. That intrapulmonic pressure increasing, or the phase of exhalation, results in a net movement of air out of the lungs. And so when we further examine some of the changes that occur during our lung function test, you'll notice that we start a test with a series of normal breaths. Now, this series of normal breaths we're going to call tidal volume, and each of these upward strokes corresponds to an inhalation. A downward sweeping stroke corresponds to an exhalation. So this would be an inspire, an expire, an inspire, an expire. Now you'll notice there are a series of 5 breaths here. In and out, that's 1, it's 2, 3, 4, and 5. Now after the 5th normal breath out, the participant is then asked to take a maximum inhale. Draw as much air as you possibly can into the lungs. So this drawing of the air into the lungs creates a maximal volume of air in the thoracic cavity, at which point the participant is asked to, as forcefully as possible, blow out all of their air. So that forceful exhale should be done with as much air moving out of the lungs as quick as possible. So this breath out may not take very long, but it should be long enough that all of that air moves out. Now, sometimes a person gets to the end of the exhale and thinks that they've gotten all of their air out, when in reality, because of that change, that small difference in pressure, air is still moving out of the lungs. So it may take 2 or 3 seconds of this maximal exhale to fully ensure that all the air gets out of the lungs. So that exhale, where it's very forceful at the beginning, during this first second of time, we get most of the air out. During the second second, we're getting a little bit more air out, and then during the final third second, we're ensuring that we've got all the air out. So at this point, the participant resumes normal breathing. We go back to this normal sweeping tidal volume that you see here. Now on this figure, we see a number of different components, and this is what you're going to be analyzing in this week's laboratory experience. As we look at the person's tidal volume, you'll notice that we have these up and down strokes, and we have this series of arrows right here under the right above the label tidal volume. So if we were to measure from the top of these peaks to the bottom of these peaks, this distance or volume of air would be our tidal volume. Now, if we were to measure from the end of a normal inhale, so after a normal inhale, that would be this line, this peaks right here. After normal inhale, if we then ask the person to inhale further, as much as they can, that would be up to this point. So the difference here from the end of a normal inhale, or from this point right here, this point right here, this point right here, all the way up until the maximal inhalation, this would be the inspiratory reserve. The amount of air that a person can move into their lungs after a normal inhale. And that makes sense because it's for normal inhale from here, and this mark up to this mark, or this line, would be inspiratory reserve. Now, we also have expiratory reserve. This would be after a normal exhale, how much air can we move out of the lungs? And so if we said a normal exhale would be on the downward stroke, so that would be at this valley, This would be corresponding to this line right here. After a normal exhale, how much air can we further move out of the lungs? Well, we said that this was the maximal amount of air moved out, so it would be this line here. This right here would be expiratory reserve volume. From the normal exhale to the point of maximal exhalation. That would be this. Now, the next one that we see here is vital capacity. After a maximal inhalation, what is the maximal amount of air that we can move out of the lungs? That would be to this point right here. So after a maximal inhale, breathing as much air as we can in, breathing as much air as we can out, from this point here, or this line, to this line, this volume would correspond to vital capacity. The next we see here is expiratory capacity. You'll notice it's slightly different than your expiratory reserve. Expiratory reserve goes from the normal exhale to the maximal exhale. Expiratory capacity goes from a normal inhale, or this line here, normal inhale, to a maximal exhale. And then obviously you can determine that if we have an expiratory capacity from a normal inhale to a maximal exhale, inspiratory capacity is from a normal exhale up to a maximal inhale. So in theory, this line, it's represented over on this side of the figure, but in reality, it's really any of these valleys from this line that's touching this line, any of these valleys, so from here to here would be inspiratory capacity. From here to here would be inspiratory capacity. So that gives us inspiratory capacity. We also see a couple other terms here, functional residual capacity. We have residual volume and then total lung capacity, and these are other marks that we're going to measure in the lab. So your introduction document for pulmonary function illustrates a lot of the material that you'll need to know as it pertains to the understanding of what we're measuring in lab. But again, we can see some of the figures that we just saw a moment ago, including this example of the respiratory volumes and capacities. And again, as I described some of them, you do have some additional information pertaining to those. Briefly, I mentioned the functional residual capacity. You'll notice that the functional residual capacity is comprised of the expiratory reserve and residual volume. And we haven't talked about residual volume, but residual volume is the amount of air that's left over in the lungs after a maximal exhale. So residual volume is the amount of air left over in the lungs after a maximal exhale. And again, we see an example of that definition in our document. So we have a number of different methods that we could predict a person's vital capacity. If you'll recall, vital capacity is the maximal amount of air that we can move in and out of the lungs. So the total volume of air, the maximal amount of air that we can move after a maximal inhale and a maximal exhale, the largest amount of air that we can move in and out of the lungs. So we have some prediction equations, so we could, in theory, predict a person's vital capacity. To do that, we would need to know the person's height in centimeters and a person's age in years, and that would give us a prediction depending on whether we use the male or female equation. Now, your procedure document for the pulmonary function lab outlines first your calibration, so you would set up your tachometer here, or your pneumotachometer to measure airflow. To your Biopac, you would enter your subject demographics with their age and height. Down below, further in this document, you see the calibration, and to calibrate, we're going to use this syringe here, and this syringe is a constant or known volume of air that we're going to enter into the machine, and so that it can determine how much air is actually being moved compared to the stroke of that calibration syringe. Now, once we've finished the calibration, we'll go ahead and begin our data recording. Now, the data recording is fairly straightforward. A participant would be positioned with the flow meter, with a filter, and with a mouthpiece. That would then be inserted into the mouth, nose clip to block airflow from the nose so that all the air moved during this test is going directly through this flow meter. And the tests that we're going to do here, we're going to do a test that looks very similar to that chart that we illustrated a moment ago, with a couple normal breaths. So this would be an inhale and an exhale, and an inhale and an exhale, inhale, exhale, inhale, exhale, and then a maximum inhale and a maximum exhale, and back to normal breathing. And that's our test. Now, if you have a test with a tilted line where we have a wandering baseline where this line should be flat, you're going to need to redo your test. So this would be excessive tilt in the volume data. So if the recording does not resemble this figure here, you need to redo it. That means if there's a noisy or flat line, if we didn't get a proper line, if it looks like it has a lot of artifact or it doesn't look as clean, we need to redo that. Double check all your connections because it could be into the wrong port. If there's excessive tilt, make sure you redo that, and that would complete the recording. So it's pretty straightforward in terms of our lab for lesson 12, going through a series of breaths. The primary focus here is we are trying to collect the different volumes, so tidal volume, inspiratory reserve, expiratory reserve, residual volume, inspiratory capacity, expiratory capacity. So that's the primary focus of today's lab, to better understand some of these capacities and flows. So when we do our analysis, as you go through your data analysis, you're going to see on your Biopac BSL data sheet the table for all of your volume and capacity. So this would be your data sheet that you're going to fill out for this week's lab. Obviously, your participant, you'll enter their name, height, sex, age, and your name would go up in this corner here. Now, for your participant, we'll determine the equation that we'll use. We'll estimate a predicted vital capacity. Then this would be our measured vital capacity, and we're also going to fill in this table down here with tidal volume for all of these values. So let's start right here with our observed vital capacity. So if we open up our Biopac data, you'll notice that we have this clean set of data with 5 different breaths. Now, as an example, I'm using the sample data from Jared, but you'll be sure to observe which data you will be analyzing for your lab experience. So the first part we want to analyze is for Jared, and it's his vital capacity. Now, if you'll recall, in this analysis, if you scroll down just a little bit, we have an example of vital capacity. And again, as I mentioned, it was from the peak or maximal inhale to the maximal exhale. So that's pretty simple to do. The first thing is to click on the I-beam over here, and then click on the maximal inhale, and then let's scroll over to the maximum exhale. So remember, these are 5 normal breaths: in, out, in, out, in, out, in, out, in, out. Okay, maximal inhale and maximal exhale. Now it's from the maximal inhale to the maximal exhale that comprises our 2 P-P 4.317 liters, or 4.317 liters. So we would say 4.317 liters would go right here in this box. And then we would compare the observed versus the predicted. Now you would have to calculate for Jared based on his height and age what his predicted would be, and then we'll take the observed divided by the predicted. Now, to fill in this table here, it's going to look very similar to what we just did, except we're going to do it for our different components here. Let's start with tidal volume. Tidal volume, again, we're going to use the 2 P-P value, and we're going to use cycle 3 inhale and cycle 4 exhale. So to do that, if we look at this analysis data sheet, you'll notice that here's our first cycle, second cycle, third cycle. So in this example of cycle 3, they are measuring the inhale selection. So that would be from this point right here to this point right here. Okay, this would be from a normal exhale, inhale. Okay, cycle 3. So this would be what we measure for the inhale selection. Now if you'll scroll down, you'll notice that on this one, they're measuring from the back half of this tidal volume. So this would be from the exhale. So from the point here to the point here would be example of cycle 3 exhale selection. So let's go back to this data sheet. You're going to need to do this for both cycle 3 and cycle 4. And then we'll calculate the average and we'll put that value right here. So if we have a value for cycle 3, inhale, exhale, add up all those, divide by 4, gives us an average here. That's what we'll use. Okay, so if we go back to our figure, you might need to reference this throughout the analysis because this is going to help you to understand what it is that you're measuring. So again, if we look at our Biopac data, this was measuring vital capacity for the first part. Now the second part, we needed to look at cycle 3. 1, 2, here's cycle 3. So from this valley to the peak, this would be inhale. We'd measure the 2P to P. We'd use 1.1 liters. Okay, this right here, 1.1 liters, would be our inhale value. Okay, now we're also going to look at the exhale for cycle 3. So we'd go from the peak here to the valley here. This would be our exhale, 1.198 or 1.199. Then we'd do cycle 4. We'd measure this, 1.008, and we'd measure cycle 4 exhale. Let's get that right from the peak down to the valley. We'd use 0.9335. So this information, I've really just calculated all 4 of these. I called them out. You could be writing those down as you were going, but I've just done all 4 of these. So that's now complete. And now we're going to go on to inspiratory reserve volume. So recall for inspiratory reserve volume, that right here is from the peak of a normal inhale to the top of this vital capacity or maximal exhale. So in reality, I could measure it from any of these points, from here to here. I could measure it from here to here. I could measure it from here to here. It would be all the same if our baseline is consistent and if our tidal volumes were all equal. Now from that previous example where we measured 4 different inhale, exhale, you notice that all of those were slightly different. So all of those would have slightly different values in reality if we were to measure the inspiratory reserve from each of those. But for the purpose of our lab today, we're going to analyze inspiratory reserve using the peak that's closest to the maximal inhale. So that would be our 5th peak. So if you measure from here to here, you'll notice that this would be our inspiratory reserve. So let's go to our Biopac data. So here, if we were to measure again from this point right here, I click and drag to this point right here, you'll notice that this gives me my inspiratory reserve, 3.365. This would be my inspiratory reserve. Now, one of the other things that we've done here without knowing is I've also highlighted at this point my maximal value because see, I've highlighted from here up to the maximum. So this value right here, 2 max, we're also, while we've got this highlighted, we're also going to use this value. Let's go back to our data sheet. Take a look down here at total lung capacity. Do you see here 2 max? Well, while I have that highlighted for my inspiratory reserve volume, it's also asking me to look at what's the maximal value on this highlight. Well, because we've got the maximal value highlighted here, it's going to give me this maximal number. We're going to enter that for our total lung capacity. So with that, you should be able now to calculate your final values for your inspiratory reserve, your expiratory reserve, residual volume, all the way through each of these, making sure that you're looking at your values. Are you using the 2P to P? Are you using the 2 delta? So for inspiratory reserve, I think I mentioned 2P to P. Let's correct that because it very clearly says 2 delta. So let's go back and let's look here. So from this example, from here to here, let's make sure that we use our 2 delta value. Okay, here would be our 2 delta value. So this right here would be inspiratory reserve. So this is one opportunity where if you get going too fast, you'll make an error like I just did. So do not make that mistake. Make sure that you are measuring exactly what your data sheet asks you to measure. So for inspiratory reserve, which we had correctly highlighted, we need to make sure we use the 2 delta value, because that is going to be the value for inspiratory reserve. Not any of these others. Those don't correspond to inspiratory reserve. Okay, let's go back to your data analysis. So all of these give you your example when you go through. Here would be your total lung capacity. It talks about that as well as you go through. Now, one of the other areas where you might need is to measure your minimum value. So if you look at this figure here, you'll see that we have our vital capacity going from the top all the way to the bottom. You have your expiratory capacity. One of the things that you could do is when you have your minimum value highlighted, you'll notice that on the data sheet, you're asked to provide 2 minimum. So it's asking you what your 2 minimum is. So when we went to do our expiratory reserve volume, let's say for expiratory reserve volume, we said, okay, it's from the point of a normal exhale to this minimum value. You'll notice from the expiratory reserve volume that I have highlighted, from the minimum exhale to the maximum exhale, we're going to use, again, let's do this properly, 2 delta. Now, because we've also got the minimum value highlighted, similar to the maximum that was highlighted during the measurement of inspiratory reserve, where we wrote down lung capacity, total lung capacity, we also have 2 minimum. So here we have 2 delta. And if we go from this location to this location, you'll notice in this case, my 2 delta is negative. Now, in reality, you don't have negative lung values, but it's taking these values and it's subtracting them, and so the computer program doesn't decipher the differences in total volume. It just says this value minus this value. In this case, it gave us a negative. Well, the reality of it is, it just depends on the direction that you highlight. See, because if I highlight from this direction to this direction, now I have a positive value. If I highlight from this direction to this direction, I have the same value, but now it's negative. So when you write down your value, always write down the absolute value, the positive number. Okay, so create the positive number, because these values should always be positive as you write that down. You'll notice that I have the minimum value highlighted. Again, here we'll use 2 minimum. 1 liter is the estimate for residual volume. So if you have any questions, please reference this chart that's in the analysis document. As you continue to fill in your data sheet, you'll enter all of your data into the points here. Adding up tidal volume and inspiratory reserve volume gives us your inspiratory capacity. So you're going to measure inspiratory capacity, and then you're actually going to add your tidal volume from this box here, plus your inspiratory reserve from this box here. And this value and this value should be very similar. They may not be identical because we're using different values, but we could go and we would just calculate the values based on adding tidal volume plus expiratory reserve plus residual volume, inspiratory, tidal volume, expiratory reserve, and residual volume to get our value for total lung capacity. So with that, you'll have a couple other components of your data sheet. So this is saying tidal volume. So if a resting subject's normal breathing tidal volume is approximately 500 milliliters, was the measured volume of your participant for tidal volume, this value right here, was this value right here greater than, equal to, or less than 500 milliliters? You'll do that for inspiratory reserve. If it was a male, we have approximately 3,000 300 milliliters or 3.3 liters, and you'll want to know from your value of inspiratory reserve, was the calculated value greater than this, equal to this, or less than this. Now if it's a female, we'll use 1,900 milliliters or 1.9 liters. You'll determine was it greater than, equal to, or less than. Don't forget to fill in the answers to your discussion questions below the data collection sheet, and that'll be what you'll turn in for this week's lab write-up.